So far, we have talked about decision trees and bagging and boosting. We have looked into random forest, which is a good example of bagging algorithms. Now we'll be looking into gradient boosting, which is an example of boosting based algorithm. So just to recall what boosting does, it is a sequential form of developing learners or models where we try to start from a weak learner and kind of successively iterate over this weak learner and develop a strong learner. Our effective goal over here is to reduce the error from the precursor model. That is, on every iteration, we are reducing the error that is coming as an output of the first model. Gradient boost takes it a step further. Gradient boost is a combination of two technologies. One is known as the gradient descent and the other is the boosting algorithm. We are familiar with boosting algorithm. Now let's take a look into what gradient descent is actually about. Gradient descent is an optimization algorithm which tries to reduce the loss function, which in actual fact tries to get to the minimum loss function that we can get. So it effectively gets us to the minimum error that is possible from the entire algorithm. Gradient descent can be thought of as an exercise that a person can do to get to the top of a hill. Suppose the person is blind and he wants to climb to the top of the hill. How would he understand if he has reached the top of the hill? He starts off from a point and he tries to understand at what point of his climb is he not climbing anymore. That is, he's trying to go down. So essentially, as and when he's increasing in the altitude, that is, he's giving effort to climb up the hill, he can understand that he has not reached the minimum or the maximum point of the hill. And as and when his next step gets him a little lower, he can understand that he has reached the top, or in our case, the minimum loss of the function. That is the minimum error that can be present in this given function. So this is how gradient boosting algorithm works. It essentially develops a loss function, which is the function of the error that is present in the model, and it differentiates these functions and tries to get to the minima of this particular function. And at each successive level of the modeling, we try to reduce the error, and in doing so, we reduce the bias of this model and hence reach a particular point where the model has the least possible bias that can be associated with it. With this model, we can safely say that it is much more better than a single decision tree, and hence it is much more efficient than a single decision tree. So this is in essence how the gradient descent algorithm works. Now, what are the advantages and disadvantages of using gradient descent algorithm? So the advantages is that it supports a differentiable loss function. So if the function can be differentiable, it can be computed. That is, we can allocate computational resources to calculate the loss function and how the characteristics of this loss function is changing. And the third part, and the second advantage that is present with gradient descent algorithm is that it works well with various interaction effect. So when we have multiple features, some features can interact with other features to give a sort of unique results. These interactions are effectively captured by gradient descent algorithm, where we are only concentrating on the loss function and every sequential model is actually reducing the error. So we are effectively able to capture the interaction also between the various features that we are using. However, like as good things have a bad side to it also, similarly, the disadvantage of gradient boost algorithm is, since it tries to reduce the error, it has a tendency to become overfitting. That is, we may overfit our model to the entire training data set. To prevent this thing, we have certain hyperparameters that can be tuned with gradient boost algorithms which prevent overfitting. Hyperparameters are user input values which prevents a tree-based algorithm from overfitting the particular training data set. And also, along with this hyperparameters, we also increase the time that is required to develop this model. Since now we are not just concerned with the parameters of the model and the training data elements, we are also concerned with hyperparameters which are user input data, which needs to be optimized so that to prevent our gradient boost algorithm to overfit this particular data. However, in current times, gradient descent based algorithms or gradient boosting is very popular, as it enables us to reduce the bias and has hyperparameters to prevent overfitting of the data. So it has best of both worlds associated with it. And it is one of the most popularly used technique by data scientists nowadays, especially to build decision tree models, which kind of reduces the bias and the variance of the model. With this, I would conclude this session on gradient boosting algorithm and hope to see you in the next chapter. Thank you very much.